Good morning, my dear students. Let's continue the chapter Magnetism and Matter. So today's session is about important terms related to the magnetism. See, these are the important terms we'll be frequently using while describing the magnetic properties of magnetic materials. Each and every substance available around us can be classified under the categories of magnetic materials. Every substance you can take. So those magnetic materials around us, the substances around us, are classified into three categories. Carefully listen. Diamagnetic substances, paramagnetic substances, and ferromagnetic substances. If you take a strong magnet, imagine a strong bar magnet if you consider, and place close to this diamagnetic substance, and this diamagnetic substance will be feebly repelled by that strong magnet. This paramagnetic substance will be feebly attracted by that strong magnet, and this ferromagnetic substance will be strongly attracted by that strong magnet. This attraction and feeble repulsion is based on, simple thing here, there is an external magnetic field is created due to the strong magnet, whatever I had just mentioned. So imagine that external magnetic field is B naught. In this external magnetic field, these magnetic substances are kept. Imagine this is the magnetic substance are kept. Alright? Due to the position of this object, that may be any kind of magnetic substance, there will be total magnetic field will be produced inside. Magnetic field strength is a vector quantity, as B naught is a vector quantity, and this total magnetic field is also a vector quantity. Depends on these two values. This particular magnetic substance may be feebly repelled by this external magnetic field, or may be feebly attracted or strongly attracted by the external magnetic field. Remember. So what you should understand here, so this is B naught is external magnetic field, and this B is total magnetic field produced in a substance. Total magnetic field produced in the substance, remember. And one more important point I will tell you. Mainly this categorization is taken place from magnetic permeability values. We know about mu. Mu is magnetic permeability. About magnetic permeability we will be discussing in detail now. Okay. And before moving to that, and one more important point I just wanted to tell you. There is a magnetic field produced in this. So this B is the total magnetic field due to this one and due to the magnetic field produced by the substance. But B suffix M I can write, which is equal to the magnetic field produced in the substance. Magnetic field produced in the substance is different. Total magnetic field produced in the substance is different. This is only due to this Bn is only due to the substance. This B is due to B naught and the substance. Got the point? Now, look at the interesting thing. Let's come back our important terms related to the magnetism. The first important term is a magnetic permeability. What is that? A magnetic permeability, which is denoted with the symbol mu. From the lower classes, you might have learnt about the magnetic permeability. What exactly meant by the magnetic permeability? It is similar to the permittivity in case of electric charges. There is a magnetic substance is kept here. The magnetic permeability will be there. It is a property of a particular magnetic substance. What this property does? The ability of alloying the magnetic field lines. Understand? The ability of alloying the magnetic field lines by the substance is called a magnetic permeability. So simple. Magnetic permeability is the ability of a substance in alloying the magnetic field lines. So you can say if the mu value is more and that particular substance is more able in alloying the magnetic field lines through it. Simple. Mu is more, it is more allow the magnetic field lines through it. And this magnetic permeability mu R, what is that mu R? Relative magnetic permeability. So that is relative magnetic permeability. So this relative magnetic permeability is mu by mu naught. What is this mu by mu naught? Mu is permeability in a medium, in this medium. This mu naught, permeability in free space. We know everything about this. So here mu naught value also we know 4 pi into 10 raised to minus 7 Tesla meter per ampere. And this relative permeability, listen carefully, this relative permeability can also be written as B by B naught. No confusions at all. B is the total magnetic field produced in a substance by B naught. B naught is the external magnetic field. Remember, the same relative permeability can also be written as B by B naught. This is magnetic field, this is magnetic field. There is no unit and there is no dimension for these relative values. Relative permeability, relative permittivity, refractive index. There won't be any dimensions and there won't be any units also. It is just a number. Remember, these two are same. What you should understand here about the relative permeability, listen to me carefully. So your mu R value will tell about a given substance is a magnetic substance or a non-magnetic substance. If the relative permeability values are equal to 1, then you can say that given substance is non-magnetic in nature. Like air, glass, plastic, wood, etc. Right? Water, or you can also say cotton. So these all comes under non-magnetic substances whose relative permeability values are 1. So if a given substance whose relative permeability is not equal to 1, that means it may be less than 1 or greater than 1, then those substances are called magnetic substances. Alright? Now, let's move back to the diamagnetism, paramagnetism and ferromagnetism substances. And these diamagnetic substances, I am writing here, these diamagnetic substances will be having relative permeability values. Listen, relative permeability values are less than 1 always. Always less than 1. Less than 1 means the values will be negative. So, in case of paramagnetic substances, so your mu r will be just greater than 1. So in case of ferromagnetic substances, the relative permeability values are far greater than 1, right? Depends on these values only. The basic classification has taken place, and that's what I've told you here. All right. Now actually, most of the students will leave the topic because they feel that it is difficult. There's no difficulty involved in it, right? Now, number 2, the second important term related to the magnetism is a magnetizing force. What is that? A magnetizing force denoted with the symbol H bar, or magnetic intensity denoted with the symbol H bar. No confusion. Magnetizing force and magnetic intensity. Same thing. Magnetizing force or magnetic intensity is, look at here, we have kept an object inside the external magnetic field. Immediately what is happening? This external field will magnetize the given substance or kept substance. Understand? This external field will magnetize the substance which is kept inside. That's called the magnetizing force. What is that called? Magnetizing force or a magnetic intensity. And this magnetic intensity, H bar is written as a B by mu. See here. H bar is equal to B by mu, or B naught by mu naught. I am writing R. The same H bar is equal to B by mu. Okay. So H bar is a vector quantity. So this I can say it is a vector quantity. It is a vector quantity here, and whose units will be, you can see this is Tesla and this is Tesla meter per ampere. Okay, this is Tesla and this is Tesla meter per ampere. So what I can say, so the SI unit, you can also do that, Tesla by Tesla meter per ampere. SI unit will be ampere per meter. So it is a vector quantity. SI unit also I have written here. All right, clear? Now this I can also write, listen, this I can also write, your B naught is equal to mu naught into H, or B is equal to mu into H. No confusions. The most of the students will miss the point here. The point is, you know, in the case of toroid or in the case of solenoid, what we had discussed, the magnetic field produced inside the toroid or inside the solenoid will be a mu Ni. For example, if I consider permeability in a medium. But we have B is equal to mu H. You see here, B is equal to mu H. B is equal to mu, and H value you can see, N into I. If you compare these two, you get your H is equal to N into I. What is that N? Number of turns per unit length. N is what? Number of turns per unit length. N is number of turns per unit length, and I is current passing through the solenoid or toroid. Understand? So this H, your magnetizing force or magnetic intensity, can also be defined as the product of number of turns per unit length into current passing through that. And you do that, number of turns per unit length into ampere. 1 by length into ampere. That's called ampere per length. Length SI units are meter. Ampere per meter again. The SI unit again you get it as ampere per meter. You understand? Clear? Remember this expression. These all expressions are important while understanding the next slide. Number 3, the third important terminology which we will be using frequently while describing the magnetic properties of materials is intensity of magnetization. Is denoted with the symbol I bar. As I bar I wrote, and this is also a vector quantity. I bar, vector quantity. What is this? Intensity of magnetization. How strong this external magnetic field will magnetize the material which is kept inside it. That's called intensity. How strong, how able, up to what level, up to what order the external magnetic field can make the magnetized material which is kept inside. That's called intensity of magnetization. Okay? Understand? So the intensity of magnetization, I bar, is equal to the ratio of magnetic moment per unit volume. The ratio of magnetic moment per unit volume, and I am writing here, so M bar is a magnetic moment. No confusion. M bar is magnetic moment. You know about the magnetic moment, which is the product of length of the magnet and pole strength. Right? So this is magnetic moment. SI unit is ampere per meter square divided by volume is meter cube. Meter square cancel, and here also you can say the SI unit will be ampere per meter, and the SI unit of intensity of magnetization and SI unit of magnetizing force will be same, ampere per meter. Any confusion here? Any confusion here? No, right? So here, this sometimes can also be written as I bar is equal to pole strength into length of the magnet. That's called the magnetic moment by volume. What is the volume? Imagine you have taken a bar magnet whose area is A into length is 2L. So here 2L cancel, and intensity of magnetization sometimes can also be written as magnetic moment per area. Sorry, magnetic pole strength per area. Unit you get the same. Magnetic pole strength per area. So in this way also you can write. Understand? Clear? So 3 are finished. And the 4th one is the very important one. That's called magnetic susceptibility. What is it called? A magnetic susceptibility. So that we will be discussing now. Is magnetic susceptibility denoted with the symbol Xi suffix M. Xi. It's a Greek symbol. Magnetic susceptibility. In simple words, I'll tell you. If the magnetic susceptibility is more for a material, right? If the magnetic susceptibility is more, and we can easily magnetize that material. If it is less, it is difficult to magnetize. More magnetizing force or more magnetizing intensity, so we need to apply. The external magnetic field application must be maximum if the susceptibility is less. Okay. And we have diamagnetic substances, paramagnetic substances, and ferromagnetic substances. Here itself I'll tell you, your susceptibility in case of diamagnetic substances is less negative, and here it is less positive, and it is more positive, remember. So the diamagnetic substances, it is almost impossible or very difficult to magnetize it. Here, it's difficult to magnetize, but it's okay. These are the substances, ferromagnetic substances. iron, nickel, cobalt. Those are the substances, they are easy to magnetize. Simply, low intensity of magnetizing field, if you apply an external magnetic field with a less magnitude you apply also, these substances will get easily magnetized. Okay? When they get easily magnetized, in the same way, easily they get demagnetized also when you remove the external magnetic field, remember. How easy the magnetization, in the same way a demagnetization is also takes place easily in case of ferromagnetic substances. Alright, come back to magnetic susceptibility. And this magnetic susceptibility is the ratio of I bar by H bar. What is I bar? Intensity of magnetization, whose units are ampere per meter, and H bar, whose units are ampere per meter, and this H bar is magnetizing force or magnetic intensity. Magnetic intensity is different and intensity of magnetization is different, right? For your better understanding, here itself I write what is the numerator. Numerator is intensity of a magnetization. Intensity of magnetization divided by, what is this? A magnetic intensity. No confusions. Alright. No units, no dimensions. No units, no dimensions. It is just a numerical value. Now the most important part of the session and this chapter, there is a probability of getting a question in your NEET, JEE or CET exam on this topic, what we are going to discuss now, right? So that is the topic is relation between mu r and xi. What is the relation between mu r and xi or xi m? No worries. So we are going to find the relation between them. It's so simple. What we have discussed in the last slide is there is an external magnetic field B naught, and there is a object is kept in this external magnetic field where total magnetic field is inside this magnetic substance is B, and B a suffix m is the magnetic field produced by the substance in the substance here. So what I can say in that case, total magnetic field will be B naught plus Bm. Okay. And this B from we have H is equal to B by mu, or H is equal to B naught by mu naught. From this what I can write B is a mu into H, which is equal to B naught a mu naught into H plus, this is important here, Bm. What is this? The last slide I had written what is Bm. Bm is magnetic field produced by a magnetic substance, only by a magnetic substance, where this B is total magnetic field. Okay, so this is mu, listen, this is mu naught into I. So this is the very important thing you should understand. So remember, this is an experimental value, but there is a derivation behind that. The derivation will be based on I. What is that? Based on I. So here I can write I is equal to, so m bar by V. Based on that you can derive this, but for time being remember it as Bm is equal to mu naught into I. Right? Now mu H is equal to mu naught into H plus mu naught I. Here this is the equation I'm just dividing with mu naught H. Mu naught H. Look at here. mu naught h, and just dividing both the sides with mu naught h. H cancel, it is 1 and this is here. See, mu by mu naught is mu r, which is equal to 1 plus I by h is xi. That's it. This is the relation. And here, xi m is equal to mu r minus 1. Alright. So this is the concept, and very important relation is this one. My dear students, the numerical what I have written here, this was asked in your NEET 2020. You can also check. In the last NEET exam, which is conducted in this month itself, you can check. An iron rod of susceptibility 599. So what is given here? Magnetic susceptibility is 599. I told you here, it is just a number. You can see, check here. No units and no dimensions, and it is just a numerical value. Subjected to a magnetizing field. What is a magnetizing field? Is it denoted with I bar? I bar is intensity of magnetization. It is a magnetizing field. H bar is given as, I am writing this magnitude, right? Ampere per meter. H ampere per meter. See, 1200. Now, the permeability of the material. The question is permeability of the material. What is the permeability of the material? Mu. That's it. They are asking mu. What is the relation we have? Let me write 3. Mu r and xi. This is mu r. 1 plus xi. You know the xi value. 1 plus xi value you get, and you get mu r. So we have mu r is equal to 1 plus xi. So that is 1 plus 599, which is 600. 600 is mu r. This can be written as mu by mu naught is 600. So then mu is equal to mu naught into 600. Mu naught value is 4 pi into 10 raised to minus 7 into 600. Okay. So this I can also write it as 24 into pi into 10 raised to minus 5. Understand? So that's it. This is the question asked in the previous meetings. Is it easy? Tell me. It's so simple. No confusions at all. It's direct formula based. And 90% of the previous NEET exam question paper was based on just the formulas. Just the formulas. That's the reason from the day one I'm telling you, maintain a formula book. At least now. If you have not done it, at least now, start maintaining a formula book in physics. That will definitely save you, I'm telling you. Right? So not only in this. So obviously, of course, this year NEET question paper was too easy in physics. Even in any other year, it may be in the next year even, 50% of the questions will be formula based. 50%. Easy to score 100 marks. Right? Now, next. There is a bar magnet is given whose mass is 75 gram, whose magnetic moment is mentioned and density is mentioned. This is density. Okay, it's mentioned, and the question is to find intensity of magnetization. Question is to find what? Intensity of magnetization. So my dear students, intensity of magnetization is equal to magnetic moment per unit volume. Here volume they have not mentioned. So that's the reason magnetic moment by, so volume I can write it as density is mass by volume. Volume is mass by density. So what I can write, it is mass by density. So this is magnetic moment into density by a mass. Understand? Substitute everything, magnetic movement, density, mass, everything you have, you get it as 0.09 intensity of magnetization. Intensity of magnetization unit is ampere per meter. Even H units are also, magnetic intensity units are also ampere per meter. This you can see here. Where is that? See, magnetizing field, 1200 ampere per meter. Okay. All right. So we will be discussing some more numericals and about the diamagnetic, paramagnetic and ferromagnetic substances in the next session. All the very best.